Some days you want to do repair work, and some days you just want to space chat about pull-up resistors. Pull-up and pull-down resistors make the state of digital pins certain. They're not a special type of resistor. Think of it more as a task than as an object. The reason we may often need to use pull-up or pull-down resistors is due to the three main states of digital logic. You've got 1 or high, true, or on. There's 0 or off, low, or false. Then there's a third state called high impedance, which is also referred to as tri-state, high Z, or floating. This means that the value is floating between high or low or on and off, and a floating pin is not something that we want. When this happens, any voltage that it's detecting isn't due to the actual task we're trying to perform. It's due to some sort of outside source, environmental factors, or electromagnetic fields. Because of this, a pin will flick between 0 and 1. It's in that uncertain state. The basic task of pull-up and pull-down resistors is to ask, what do you want the state of the pin to be when it's not connected to anything? If you want it to be high, you use a pull-up. If you want it to be low, then you use a pull-down. Both are useful for different things, but pull-up resistors are a lot more common. Here's a simple demonstration of this effect using the Arduino Uno. I've got a pin that isn't connected to anything, and I'm just reading the value of it and printing it to the LCD. You can see that the state is constantly switching between 0 and 1. If you place a resistor between the pin and ground, the value gets locked at 0. This is a pull-down resistor. It's pulling the pin state down to 0. If you put the resistor between the pin and VCC, the value gets locked at 1. This is a pull-up resistor. It's pulling the pin state up to 1. Now it's prevented from being stuck in that uncertain state. This is really common when using things like push buttons. The act of pressing the button causes a circuit to be completed. Back to the demonstration, I've added in a push button and changed my code to read the button state instead of the pin state. It's floating between 0 to 1 just like the pin did. One side of the button is connected to digital pin 7 on the Arduino, and the other is connected to the ground side of the power rail. If I put the resistor in line with the button pin connected to 7 and connected to VCC, it locks the button state to 1, just like it did with the first pin that we looked at. You can do the exact same thing by moving the resistor to ground and the opposite button pin to VCC. That locks it at 0. Now with the resistor set as a pull down, pressing the button changes the button value to 1. If I switch them the other way again to turn it into a pull up, pressing the button changes the button value to 0. Since intuitively it's easy to think that pressed would mean on, usually you'll see beginner tutorials using high when they're saying that a button is being pressed. So something like button state is high and LED state is high in order to turn an LED on. This isn't incorrect, it can just be kind of confusing and feel backwards when you start seeing tutorials later doing it the complete opposite way, saying that a button state of low turns an LED to high. The reason for that is the Arduino's built-in pull-up resistor. Instead of connecting your resistor to the ground or the VCC side of the power rail, you just change the pin mode to input pull-up. This only works for pull-ups though. There is no built-in pull-down resistor for any of the Atmega microcontrollers. If I remove the resistor and change the button's pin mode from input to input pull-up, it's locked at 1 and pressing the value changes it to 0. So now we've got a pretty good idea of the basics of pull-up resistors. They're used to make the state of a digital pin certain so that it's not floating between 0 and 1. We can make it even simpler by using the Arduino's built-in pull-up resistor and setting the pin mode to input pull-up.